Good day, doctor. I am Sasmita Davanathan, Matrix CE 2053. I'm from Group 3. Today I'm going to present assignment 2. Introduction. Nowadays, an excessive amount of solid garbage is created in urban areas. The quantity of garbage generated necessitates various processing techniques for disposal. If proper segregation and recycling techniques are not followed, as much usable material may be squandered beyond recovery. Using CNN, one way may watch and examine the visual representation of solid garbage such as bottles and aluminum cans. The input image was examined using the CNN approach, which categorizes the visual image into several subcategories. The CNN approach can distinguish between objects based on their width, height, and depth. The CNN method is also includes a range of convolutional, polling, totally linked and normalization layers. Recycling of PET bottles and aluminum cans is also necessary to ensure the world's environmental preservation and energy conservation. PET bottles and aluminum cans often come in a variety of different colors and levels of recycled importance.
Assalamualaikum and good day. My name is Nur Shafra at E100126. For this assignment 2, there are two tasks given. Both function have almost the same method and process, but slightly different to the pre-trained model. For task 2, we need to choose two model. So our group choose VGG and DenseNet. So for task 1, the process start with start, and next Google Drive may be mounted on Google Colab. Next, current working directory is checked and set after OS module being imported. And after that, vital design supporting libraries import. A data directory for validation and training established. The random input and data pictures from a list of files in the current working directory return and print. After that, the three colors channel is set to 3 with 150 times 150 picture size. After that, the convolutional neural network CNN architecture is created for M1 model, and next it will train the validation data, preprocess and rescaling. After that, the model M1 training process start, and based on the input data images returned, the feature map display in different layers. Next, the results of model M1 output plot, and then for the training and validation, does the training and validation accurate? If yes, it will end. If no, it will start back to the model M1 training process start. So uh, as I said before, for task 2, there are two models that need to be choose. So our group select VGG and DenseNet. So what is VGG? It is a typical deep convolutional neural network designed with several layers, and the abbreviation VGG stands for Visual Geometry Group. It's the term of deep describes the number of layers, with VGG 16 or VGG 19 having 16 or 19 convolutional layers respectively. Based on the coding, VGG 16 is used. So the process is the same like the task 1, but the only difference is right here. After the data directory validation and training established, the TensorFlow is imported with using VGG as pre-trained model. So, and then it will just go on like before. Only the difference is we use VGG as the model. So our second model choice is DenseNet. So by leveraging shorter connections between the layers, the DenseNet, or the long one means dense convolutional network design, aims to increase the depth of deep learning networks while also improving training efficiency. A convolutional neural network called DenseNet connects every layer to every other layer below it. For example, the first layer is linked to the second, third, fourth, and so on levels, while the second layer is connected to third, fourth, fifth, and so on layers. This is done to maximize the information flow between the network levels. So next, this is the flowchart for task 2. As you can see, it's also the same like the previous one, VGG, but the difference is right here. The TensorFlow with DenseNet is imported as pre-trained model. So we will look at the code.
Okay, now I'm going to continue my presentation by presenting task 1A. Okay, first of all, we have to connect to Google Drive. We have to connect our Google Colab to Google Drive. After we connect it, we get the output as mountain at and the link for the Google Drive that we connected. And the second step is feed dataset directory. Okay, this step is to input the operating system to get the direction of the file saved in Google Drive. And then the third is creating and validation data directory. So here where we have to create the link that to declare the pictures that we save in our Google Drive. After that, we will get the output as the can train length is 156, pet train length is 310, can validation length is 77, pet validation length is 133, total training images is 466, and total validation images is 210. And then here is the to initialize the TensorFlow and model used in the program. And the step 4 is construct the CNN model. So here is the values of our CNN model, and the output is for input underscore 1 the parameter is 0. So for conv 2D is the parameter is 896. For max pooling 2D is the parameter is 0. To conv 2D underscore 1 the parameter is 18496. For max pooling 2D underscore 1 the parameter is 0. For conv 2D underscore 2 is the parameter is 73,856, and then the max 2D pooling underscore 2 is 0, parameter is 0, and Felton is parameter 0, and then dense the parameter is 189404116, and the dense underscore 1 is 513. So overall the total parameter is 19034 and 177, and trainable parameter is 19034 177, and non-trainable parameter is 0. Okay, and then here is pre-process the input data. So here is the coding for that, and then as the result we can found that 466 images is belong to two classes, and found 210 images belong to two classes, and data page shape is 32, 150, 150, 3. Label page shape is 32. Step 6 is start training process. So here I set the epoch value as 15. So as the output we can see that the epoch of the first got the highest loss, where is 1.5194. Okay, and then step 7 is a local further expression section. Okay, this where we can visualize each image from the link. And then the next step is from this design we can visualize our local further expression section with the rendered images either pet or train. Okay, so here as the output we can see that the first layer is a heavy system with the filter. So here is the 16, and then 32, 64, 128, and followed by 256 and 512. Step 8. Plot the outcome. So here we have to plot it to get our graph. There is two graphs. First is training and validation accuracy, and the second is training and validation loss. For training and validation accuracy, the lowest is 0.6 and the highest is 1. For the training and validation loss, the lowest is 0 and the highest is 3. So from this graph, we can conclude that the value of training accuracy is greater than the value of training loss, and the validation accuracy is higher than the validation loss. Okay, okay. For task 1B, the first image that I use is pet and can stay same distance from the camera screen, and the second is can stay and pet move further backward, and the third is pet stay and can move further backward. Okay, now, first of all, we have to connect the Google Colab with the Google Drive, and then we have to feed the database directory to import the operating system to get direction, the file safe in Google Drive, and then create train and validation data directory. So for here, we have to add the three pictures we had new. So we can get the can drain length is 156 and pad drain length is 310 and can validation length is 77 and pad validation length is under 33. So total training images is 466 and total validation images is 210. So new can pad length is 3, and then followed by the initialize the TensorFlow and module used in the program. What is construct the CNN model? As I just explained before this. So here the total parameter is 19,034,177 and trainable parameters is 19,034,177 also. So non-trainable parameter is 0 and step 5 is pre-process the input data. So the font is 466 images belonging to two classes and found 210 images belonging to two classes and data page shape is 32, 150, 153 and label page shape is 32. For step 6, start training process. So here the epoch is set as a 15. So as before, the highest loss is at first epoch with 1.3156 and then step 7 is a local future expression section. Okay, first of all, we can visualize each image from name and then here is from the design can we visualize our local feature expression section with rendered images either pet or can. Okay, step 8 is plot the outcome. So here is the our graph. First is training and validation accuracy. So the lowest is 0.5 and the highest is 1.0. For training and validation loss, the highest is 4.04 and the lowest is 0. So here we can see that the training accuracy is higher compared to the training loss and validation accuracy also higher compared to the validation loss. And then we continue with this question. Okay, for this, first of all, we have to import the pictures from our Google Drive. And then for the first, pet and can stay same distance from the camera screen. Okay, for this, we get 65 millisecond per step and 100% can and 100% pet. Um, for can stay and pet move further backward. For this, we get 45 millisecond per step. Okay, here we get 100% can and 100% pet. And then for pet stay and can move further backward. For this, we get 44 millisecond per step. And here also we get 100% can and 100% pet. Okay, that's all from me. Thank you.
So I will explain for task 2, model VGG. So here is the coding using Google Colab. So right here is the result of training and validation data directory. As you can see, can training length is 156, pet training length is 310, can validation length is 77, and pet validation length is 133. And then right here, import TensorFlow as TF is where we import the TensorFlow, and then this is the coding for VGG16, means VGG16 16 layers. So after that is the model result of the VGG16 model. So the layer, output shape, and the parameter. These are the total parameters, trainable parameters, and non-trained parameters, 0. After that, so this based on the data inside of the Google Drive, it will count and found that 460 images belong to 2 classes, while 210 images belonging to 2 classes. So I use epoch for 150 to train all the data. So here is the evidence that I trained the data. So right after that, here is the training and validation accuracy. So as you can see right here, the training accuracy is 100% consistent, while the validation accuracy is 98.10%. So for the training and validation loss, the validation loss lines slightly descending, while the training loss line consistent, 0. So when I put the image to detect, for the first that pad and can in the same direction, same distance from the camera screen, it can detect 100% image for pad and can, while on the second image, that is, they can stay at the same place while the pad move backward. It can detect, it's totally 0%. I'm not sure. And lastly, however, for when the pad is the same distance while can move backward, it can detect 100% for both of it. So both of the image can be detect 100%, but not this one. So that's all from me. Thank you.
Hello, my name is Namiki. So I'm doing the presentation of DenseNet pretend model. So the first, uh, we connect the Google Drive first. So we play. So we can connect the Google Drive. Connect. So keep the permission to allow the Google Drive to connect the coding. Okay, so the step 2 is fit the data directions. So we import the file into the Google Drive. So we set the name dataset. So we import it, and the step 3 is create the trend invalidation data directions. So this is the code for the train and validation data. So this is the result. So the train length is 156, the pad train length is 310. So the validation length is 77. So the pad validation length is 133. So the total training image is 466 and the validation image is 210. So this is to import, show the TensorFlow to import the DenseNet pretend models. So after this, we do this coding to convert the DenseNet to get the result of the DenseNet. So this is the process until here. So this is the total parameters and the non-trainable parameters. Next, this is the models to do the layers. So we get the DenseNet 1 to 1 layers and the others. Okay, next, so we do the trend to get the image that get found in the Google Drive. And next, So we do the history to get the code of start training progress. So this is the training progress result. Okay, so next we do the plot to get the graph. So since that the training validation accuracy got the same value, and the training and validation loss, the validation loss is higher than the training loss. Next we got capture three pictures. There's different locations. So this is the coding for test image one. So there is used 2 seconds to scan the image. So the others, image 2 and image 3, so there's used 28 milliseconds to scan the aluminum can and PET bottles. Okay, so proceed to the next. So I'm presenting the conclusions. So the convolution neural networks CNN models are designed successfully. So we studied on different approaches of the convolution neural network CNN models. So DenseNet model is the most optimal convolution neural network CNN models that is so difficult to establish any CNN models, the most superior. So to the next. So these are recommendations. So the first recommendation is increase the number of training and validation data. So around the models to study more data to get the higher accuracy. Second, data argument can be employed that can increase the diversity of the image with technique like flipping and zooming the image. So next, the layer can be added in the models to help improve the ability of the models in the learning data set. So there's a last, the number of epochs can be increased to increase the ability of the models. So this is my presentation. Thank